Hello and welcome to a video presentation on exponents. Here's what you'll learn: how to read, interpret, and represent numbers using exponents. First of all, what are exponents? Well, exponents are a shorthand way of writing repeated multiplication. In the example below, the number 5 is called the base. The number 3 is the exponent. Another word for exponent is power. The number below can be read as the third power of 5, or 5 to the power of 3, or 5 to the third power. All three mean exactly the same thing. Just as the use of multiplication is repeated addition, the use of exponents indicates repeated multiplication. When you multiply 4 times 3, that's the same as writing 3 4s and putting addition signs between them. With powers, the exponent tells you how many times you're going to use the base number in your repeated multiplication. So 5 to the power of 3 means you're going to write 3 5s and multiply those together. Now, here's a warning. Common error coming up for many people. Many people make the mistake of multiplying the base number and the exponent together. But 5 times 5 times 5 does not give the same answer as 5 times 3. So be careful when you're working with exponents not to make that error. Here are some special properties of exponents. Any base number raised to the first power is just the base number. 7 to the first power is just 7. The decimal 0.89 to the first power is just 0.89. 10,401 to the first power is just 10,401. Remember, the exponent tells you how many times you're going to write the base number. That's why a number raised to the power of 1 always returns the base number. You only write it once. Any base number raised to the power of 0 is 1. So 7 to the 0 power is 1. 0.89 to the power of 0 is 1. 10,401 to the power of 0 is 1. Now, here's another warning, another common error that people make. Many people believe a number raised to the power of 0 is 0. But here's why it's always 1. 7 to the second power is 7 times 7, which is 49. Would you agree that multiplying a number by 1 doesn't change its value? If so, then 7 to the second power could also be written as 1 times 7 times 7, and I still get 49. So, think of all exponent problems as starting with a 1 before you start writing the base number, and it makes more sense. So 7 to the 0 power, I start by writing a 1, and I'm not going to write any 7s because the exponent is 0. So the answer for 7 to the 0 power is 1. Now here's some examples of exponents. 3 to the third power. The exponent 3 tells us we're going to write a 3 3 times, and we're going to put a multiplication sign between them, and 3 times 3 is 9, times another 3 gives us 27. 10 to the fourth power means we're going to write 10 4 times and put a multiplication sign between them. Multiplying them out, we get an answer of 10,000. 5.3 to the second power means we're going to write 5.3 2 times, put a multiplication sign between them, and when we multiply that out, we get 28.09. Finally, let's do a fraction, 2 over 9 to the second power. That means we're going to write 2 ninths twice, put a multiplication sign between them, and to get our answer, we multiply the numerators together to get a new numerator, and then multiply the denominators together to get a new denominator. Our answer would be 4 over 81. Now let's express numbers as exponents. Express the following number using a base and an exponent. We want to get the number 81 using a base of 9. The problem asks us to express 81 in an exponent form using 9 as a base and the appropriate exponent to give us the 81. Start multiplying 9's together until you reach 81. So we're going to write down a 9, multiply it by another 9. Sure enough, we know 9 times 9 is 81, so we're done multiplying 9's together. We multiplied 2 9's together to get 81, so 81 expressed as a power is 9 to the second power. Let's try another one. Express the following number using a base and an exponent, 81, but this time with a base of 3. The problem asks us to express 81 in an exponent form using 3 as a base and the appropriate exponent to give us 81. So we're going to start multiplying 3's together until we reach 81. Start by writing down a 3, multiply by another 3, that only gives us 9. So multiply by another 3, that takes us up to 27. Multiply by another 3, and sure enough we get to 81, so we can stop multiplying 3's together. We multiplied 4 3's together to get 81. So 81 expressed as an exponent with 3 at the base is 3 to the power of 4. Let's do one more. Express the following number using a base and an exponent, 125 with a base of 5. The problem asks us to express 125 in an exponent form using 5 as a base and the appropriate exponent to give us 125. So we're going to start multiplying 5's together until we reach 125. So write down a 5, multiply it by another 5. We know 5 times 5 is 25, so that's not enough 5s. We're going to multiply by another 5. 5 times 5 times 5 is in fact 125. So we're done multiplying 5's together. We multiplied 3 5's together to get 125. So 125 written with a base and an exponent is 5 to the third power. Now let's do an exponent word problem. Clarissa invented a new system for measuring the loudness of sounds. Each row in her table represents a 4 times increase in the loudness of a sound. So a loud sound is 4 times louder than a medium sound. We want to know how many times louder is an I'm not deaf sound than a medium sound. Now once again, every level, every step in the table is 4 times larger in sound than the one above it. So let's take a look now that we know that at solving the problem. The two categories of I'm not deaf and medium sound are 2 steps away from each other. So since each step is multiplied by a factor of 4, we multiply 2 4's together and we get 4 times 4, which is 16 times louder. Congratulations! You've learned about exponents, how to read, interpret, and represent numbers using exponents.